All right, let's go over the, as it said, more sample reactions worksheet. That was your work that you had to do yesterday. So in this one, what I did is I had examples of the 4 that we've had so far. Now we still have one more reaction type to learn, which is called combustion, which we'll learn probably tomorrow. So we're going to do each different type. So the first ones are combination. We're going to take 2 elements, put them together. The very first one, we got Mg plus O2. So we got to take both of those, put them together. Don't bring any numbers across. So we're going to go Mg and O, put them together. Then I have to do my charges. Mg is plus 2, O is negative 2. So those guys cancel each other. Okay, so after I've done that, now I just have to balance it. So if I do my circles, I've got Mg plus 2 O's, and it's equal to an Mg and an O. My Mg is 1 and 1, that's even. O is 2, 1. Oh, I need another one of this guy. My O's are even, but now I messed up my Mg's, so I need another Mg there. There's my answer. 1, 2, put a 2. 1, leave it blank. 1, 2, put a 2. And there's the answer for that one. All right, next one. P plus O2. And then I told you that it's going to form diphosphorus pentoxide. So we're going to go diphosphorus pentoxide. That had to make you take you back to the previous chapter when we learned how to write formulas. All right. All right. And why didn't we use the crisscross method in this one, or the charges? Because this is a nonmetal, that's a nonmetal, so this is a molecular compound instead of an ionic compound. All right, so now we got to do our balancing on it. Here's a P plus 2 O's, and that's equal to this guy that's got 2 P's and 5 O's. So we'll go back to our P's. 1, 1, 2. So I need another P. O's, I got 1, 2, and I got 5. Oh, remember the idea of an odd and an even. Therefore, we go back to the first one, double it, start all over. Well, we got 2, so we're going to double this. All right, so let's start this all over again. So now I got 4 P's, and I only got 2. So I'm going to... There we go. Now I got 4 P's on both sides. Then I've got 2 O's, and I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I need some more of these. There's 4, 6, 8, 10. There's my answer. So I got 1, 2, 3, 4, put a 4. 1, 2, 3, 4, 5, put a 5. 1, 2, put a 2. And there's my final answer. All right, last one in combination. K plus N2. All right, so this time it doesn't give us the name, so it's not molecular because it's a metal and a non-metal. So we're just going to bring them both across. We bring our K and N. Don't bring any numbers. Now I do my charges. Well, this K is plus 1, N is negative 3 from the periodic table. Crisscross those two. We're going to take the 3, put it down there. 1 goes over there. Now I just got to balance it. So I have 1K plus 2 N's, and it's equal to 3 K's and an N. Alright, so I got 1 K and I got 3 K's, so I need some more K's. There's my K's, those are evened out. N's, I got 1, 2 N, I got 1 N. So I need to do some more of this guy. There we go, there's 2 N's, there's 2 N's. I messed up my K's, so I need some more K's. Now I got 1, 2, 3, 4, 5, 6 K's, 1, 2, 3, 4, 5, 6 K's, and I got my 2 N's. All right, so go through and put down my numbers. 6, put a 6, 1, leave it blank, 1, 2, put a 2. There's my answer. All right, so those are combination. Remember combination, we're taking 2 elements, putting them together is what happens. So now we'll go to the examples of decomposition. In decomposition, we're tearing them apart. So I'm going to start with 1 compound, and we're going to end up with 2 elements. So I got AuO. So this is gold oxide. This is like, I like to call it gold rust, because rusting is actually the oxidation of a metal. That's what's actually happening here. So we're going to, lights went out. I'm going to go turn them on. All right, so we're going to tear this thing apart. So we got AU plus O. So that plus shows that we've tore these two guys apart. They're not together anymore. We're over here, they were together. Now I have to go through and decide which ones are diatomic. Remember, diatomic are those 7 around the periodic table. They make a number 7 on the table plus H. AU, is he one of them? No. Is O one of them? Yes. So we got to make him diatomic and put a 2 by him. Now I go through and balance it. So I got an AU and an O. That's equal to an AU plus 2 O's. So I got 1 AU, 1 AU. That's even. I got an O, I got 2 O's. Oh, need another one of this guy. There we go, now my O's are even. Then it messed up my AU, so I put another AU there. And there we go, now it's all done. So I got 1, 2, put a 2, 1, 2, put a 2, 1, leave it blank, and there's the answer. Alright, that was the first decomposition. Second one. GA2, S3. Alright, same idea. We're going to take these two, take them apart. Don't bring any numbers across. So we got GA plus S. Now we got to look at it and see, are they diatomic? Is GA diatomic? No, he's not. Is S diatomic? Nope, he's not. So they just stay as singles. So now we got to balance this. So I balance it. I got 2 GAs and I got 3 S's. On this side I got a GA plus an S because they're separate. So I got 2 GAs, I got 1, so I need another one of this guy. There's my 2 GAs, galliums, and then I got 3 S's, I got 1 S. So I need 3 sulfurs. There's my answer. So I got 1, leave it blank, 1, 2, put a 2, 1, 2, 3, put a 3. And there's my answer. All right, now my last decomposition one. Is BAS. All right, again, take the 2 of them apart. So we're going to take BA plus S. All right, now we have to look at his BA. Is he diatomic? Nope, he's not. Is S diatomic? Nope, he's not either. So we just leave it the way it is. And if we balance it, if you look at it, it's already balanced. There's 1 BA, 1 BA, 1 S, 1 S. So this guy's all done the way it is. We don't have to do anything. We don't have to put any numbers. It's a 1 to 1 to 1 ratio. All right, that's it for that one. Now we go on to single replacement. So first one, we got AU plus KNO3. And again, we are assuming that all of these will react. So we don't have to worry about whether or not they're going to react. We're just going to assume that they do. So we look at AU and go, what kind of charge would it have if it was ionic? Well, this guy would have a +2 because he's in the middle of the periodic table. So K is the +1 because that's the first one in the formula. So those two are going to trade places. And then the NO3 is from our polyatomic ion page. So that's what the AU is going to join up with. So we're going to get K is going to end up all by himself. Plus, we're going to get AU joins up with NO3. Oh, I brought across the number again. Why did I bring across the number? Because that 3 is on the polyatomic ion page. All right, now I do my charges. Well, is this guy diatomic? No, he's not, so he just stays all by himself. AU +2, NO3 is -1. Oh, those guys don't cancel each other, so I got to put it in parentheses, put a 2. There's my formulas. Now I just got to balance it. So I got an AU plus, I got a K, an N, and 3 O's. That's equal to a K plus an AU, an N and 3 O's, and an N and 3 O's. All right, so I got an AU, an AU. That's even. K's, I got 1K, 1K. That's good. N's, I got 1 N, I got 2 N's. Oops. Need some more of this. All right, that gets my 2 N's. Now that messed up my K's. Now 1, 2 K's. I need another K. Now that's even. All that's left is my O's. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's my answer. So I got 1 circle, leave it blank. 1, 2, put a 2. 1, 2, put a 2. 1, leave it blank. All right, there's my answer for that one. Next one on single replacement. Time I at 9. Okay. All right. AL plus CU NO32. Alright, AL, if he was ionic, he would have a +3 charge. So he's going to kick off this guy, which is positive, and that guy's negative from the polyatomic ion page. Alright, so the Cu is going to end up all by himself. Plus, we get Al joins up with NO3. Bring the 3 across because it's from the polyatomic page. Don't bring the 2 across because that 2 came from the charge. Alright, now I do my charges. First of all, is copper. Is he diatomic? Nope, he's not. So he stays by himself. Al is +3, NO3 is -1. Those don't cancel each other, so I get to crisscross them. So crisscross it, put this in parentheses, and put a 3. Alright, now I'll go through and balance it. So I've got an Al plus, I got a Cu, an N, and 3 O's 2 times, equals a Cu plus an Al, an N, and 3 O's 3 times. Alright, so I got 1 Al and 1 Al. That's even. Cu's 1 Cu. Let's make that look like a Cu. There we go. Cu and a Cu. Then I go to my ends. 1, 2, 1, 2, 3. Ooh, that's an even and an odd. So remember, we do an even and odd, go all the way back to the first guy, double him, start all over. Alright, so we got 1, 2 ALs. Oh, so I'll have to put another one of this guy. Alright, now my ALs are even. CUs, I got 1 Cu, 1 Cu. That's even. Alright, now my ends. 1, 2, and I got 1, 2, 3, 4, 5, 6. Ooh, I need some more of this guy. Oops. Put an extra one there. Now I got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 ends. Those are even. But that also messed up my CUs. 1, 2, 3. So I need a couple more CUs in here. There's my 3 CUs. All stuff are my O's. I've got 3, 6, 9, 12, 15, 18. Go over to this side. 3, 6, 9, 12, 15, 18. All right, everything's evened up. So 1, 2, put a 2. 1, 2, 3, put a 3. 1, 2, 3, put a 3. 1, 2, put a 2. And there's my final answer on that one. All right, looking at my time, we're going to go to part number 2. So we'll see you in part number 2 in a second.